Hey YouTube, Never Ending Student here. So what I have in front of me right now is an Extech LCR meter. I should be able to tilt it enough to show it to you. Yeah, 380193 Extech LCR meter, and it's one of a bunch of things I got. Sorry about that. Technical difficulties. Mechanical, with the little armature I have. Anyway, it's one of the many things I got at the Unitek auction, and I'm getting ready to put it up for sale. It works fine, but the Piezoelectric beeper in it is just eardrum ice pick stabbingly loud. It is intolerably loud. Like, I don't want to go and test the damn thing because it hurts my ears just to be effing near the thing when I press buttons. It's I don't know if it was just badly adjusted, if there should have been some RC network, if it should have had lower driving voltage, I don't know. But yeah, it's made to annoy the dead in their sleep loud. So I'm going to disconnect this. I don't know how well it'll come across, in the mic here. But you should at least be able to hear the comparison in terms of audio level. So with this disconnected, this will be how it is normally. That's painful to me. Again, I'm not sure how well that's coming across, but it's horrible. And if I hate it, my customers would hate it. So, this is a Piezoelectric beeper. I didn't know offhand how these were driven. I figured it would be some kind of waveform. It turns out it has kind of a bias voltage supplied as a baseline that doesn't cause sound. It's just there to provide the necessary power. And then typically a square wave of the given frequency is applied additionally to generate the tone desired, or the sound. So I was looking into how do I make this less crappy. And at first I was looking at just, go the simplest first. Mechanical options. To just put directly on the beeper. Oh, sorry about that. Mechanical works, but not well enough. Basically, I had to put something on top of it and then press with quite a lot of force. Like nothing I'd be able to set up mechanically in terms of just having something stuck to it. I was hoping, some rubber mass stuck to the back of the Piezoelectric beeper would act as attenuation mass for the sound. And it probably did, but it was practically unnoticeable. So if I went and pushed hard, probably we're talking like 15 pounds of force going down on a thumb size area. That was enough to work, but that's not feasible. I have no mechanical way to set that kind of force attenuation up. So that's out the window. So then I decided, all right, so we have I checked it with my meter. It's like a 5 volt baseline. And before I had looked up the specifics of it, I thought that it was just only having energy put out to it when it was actively being told to produce sound now. So I went through a few different resistor options, and like a 3.3 ohm resistor was good enough to reduce it to where I wanted. But then I checked and I saw, wait, it's getting voltage all the time. So I looked up, how these are driven. And this just leaves the baseline driving voltage of 5 volts on all the time, as long as the meter is on. So if I left a 3.3 ohm resistor on there, I'd be introducing a parasitic draw and reducing battery life, and possibly introducing way more current draw onto circuits designed for very, very low current circuitry. So that's no good. So then I thought, okay, we want to leave the biasing baseline 5 volts DC alone. So that calls for a capacitor. So I wasn't really doing any circuit math, because doing circuit math into like decibels in my head was just, I'm not going to do that. So it was just trial. My cat Floof is meowing as if we'll let off. Bad movie. Anyway, 470 microfarad, too much. So I tried a tantalum cap for, in the picofarads or low nanofarads. That was unnoticeable, so not enough. Eventually I found the sweet spot. Which one is this? Yeah, 4.7 microfarad. That looks to be the sweet spot. So we have this connected. I think I already showed you or let you listen, but it's still perfectly audible, but now it's no longer "please stop stabbing my eardrum" annoying. So I think 4.7 microfarad is the sweet spot, at least in this meter with that piezoelectric disc. Your mileage may vary if you have a need to replicate this. So try out different capacitors. Be aware in this situation of the DC bias voltage, because that's relevant in the polarity that you put in your capacitor. Make sure, negative is to negative, because it's not just AC going into it. With 5 volts, it's probably not going to, pop the capacitor, but you take an electrolytic with polarity and you reverse polarity it, you're going to introduce a situation it's not really designed for. And at the best case scenario, it'll probably just degrade over time much faster than it's designed to. Anyway, I also wanted to make sure to have a bleed resistor, just so it wouldn't hold charge forever. But I didn't want to put too much parasitic draw. At first I went with a 10K, but that was going to put like half a milliamp of draw on it all the time. And this is just running off a 9 volt. So I wanted something a little bit less noticeable, but that would still be enough of a bleed to dissipate it fully when it's just set on a shelf. So I just went with the mega ohm. So we have a 4.7 microfarad electrolytic and a 1 mega ohm, or like 900 kilo ohm really, because it's it's not like high specification extreme low tolerance or anything. And yeah, that works. So hopefully this is useful to someone. If you have an ear-splittingly loud beeper in some device and you're looking for a way to deal with it, if you don't want to beep at all, of course you can just snip the lead. But if you do want to beep, or in my case, I want to sell this to a customer and it's designed to have a beeper, so I want to leave the beeper intact, this is the solution.